All right, then, question 1. On the axis, sketch this graph here, showing the points where the graph meets the axis. Okay, this is a modulus graph. Now, generally speaking, I think the best thing to do with a modulus graph is first to sketch the graph without the modulus. So we sketch the graph y equals 4x minus 6. And to do that, I always sketch the x-intercept and the y-intercept. So the x-intercept is when y is equal to 0. So we're going to solve 0 is equal to 4x minus 6. So 4x is equal to 6. So x is going to be equal to 6 divided by 4, which is 3 upon 2, or 1.5. So that's going to be the x-intercept. And we will get the y-intercept. Y-intercept when x is equal to 0. So y-intercept is when x is equal to 0. So y will be equal to negative 6. So if I was to plot this on a graph, right? I don't know how I want to do it. So 1, 2, 3, 4, 5, 6, and then 1, 2, right? It would go down to negative 6 basically. 1, 2, 3, 4, 5, 6. We would have an x-intercept here at 1.5, 3 upon 2. And if we were to draw our line, it would basically be a straight line that would cut through the y-axis at negative 6, right? So somewhere down there. Now, the point is, when we put a modulus on this, what does the modulus do? The modulus takes everything inside and turns it into a positive. Okay, so if the value of the number inside the modulus is 3, for example, it will just give 3. But if the value inside the modulus is negative, like negative 5, it will turn it into positive 5. So we've got to ask ourselves the question, where is this graph positive and negative? Well, the graph is positive here, right, everywhere above the x-axis, so there's going to be no change. But the graph is negative down here, right, below the x-axis, so all of those values will become positive, right? So if you imagine we've got a value of negative 1, it will become positive 1. Value of negative 2 will become positive 2. So what it actually will look like is a reflection in the line of the x-axis. And that's going to include the y-intercept, right? The y-intercept, negative 6, is going to reflect and become a y-intercept of positive 6. So then basically, if I was to redraw this graph, so now if I'd redraw it, so get rid of all that, the modulus graph is going to look something like this. Try to get it right. So we'll go through there and go up there like that. Okay, and that would be our modulus graph. All right, part B. Solve the equation, the modulus of 4x minus 6 is equal to the modulus of 2x. Now, I think, to be honest, the best way to deal with this is just square both sides, right? So 4x minus 6 all squared is equal to 2x all squared. Now, the reason I'm doing that is basically the modulus, right, turns negative values into positives, and that's also the function of squaring, right? So if you imagine I've got negative 3, right, and I square it, that becomes equal to positive 9. Okay, so with the modulus, if I had like the modulus of negative 3 or the modulus of positive 3, if I was to square either of those, right, it doesn't matter, I would still get positive 9. Okay, so basically squaring the modulus is also another way basically of dealing with this whole positive negative thing. All right, so let's expand that out. So 4x all squared is 16x squared. We're going to have 4x times by negative 6, which is negative 24. But we're going to have two lots of those. So we've got negative 48x. And then negative 6 all squared is positive 36, because negative times negative is a positive. And 2x all squared is 4x squared. So now I'm going to rearrange that. So 12x squared minus 48x plus 36 is equal to 0. And I think we can divide everything through by 12, right? So x squared minus 4x plus 3 is equal to 0. And this should factorize to give x minus 3, x minus 1. I think it's hopefully quite an easy one. And so therefore we've got two solutions, x is equal to 1 and x is equal to 3. Okay, so I'm just going to quickly check the mark scheme, make sure I've got that right. I'm fairly confident. X is 1, x is 3. Yeah, absolutely right. Okay. Okay, so here we are in question 2. We want to write this quadratic in this form here, right? Basically the completed square form where a, b, and c are integers. Now to do that, the first thing I do is I just rearrange the order a little bit. So I bring the x squared to the front. That makes it easier in my mind at least. And then what I'm going to do is I'm going to factorize out that -2. So the coefficient of x squared, I always factorize it first. So I got -2 x squared minus 2x, okay, plus 3. I don't bother to factorize the 3, right, because I'm always going to have a constant at the end. In this case, it's the a there. So there's no real need for me to factorize it in this step, but you can if you want, if you prefer. And then what I'm going to do is I'm going to do the completed square method inside this square bracket. Now, how do I do that? Well, now that I've got coefficient of x squared being 1, right, I can do it without any problem. And what I do is I look at the coefficient of the x, which in this case is -2, and I divide it by 2. So -2 divided by 2 is -1. And I write that therefore as x minus 1, or x plus -1, minus -1 all squared. So let me just reiterate what I've done. I take the -2 there, the coefficient of x, I divide it by 2, which gives me -1. I stick that -1 here, and then do the same -1 all squared and subtract it off. Okay? So the general rule, if you're really, really not sure, right? If I've got, let's say, x squared plus 2kx, right? That will become x plus k all squared minus k squared. That's the rule, right? So the coefficient of x here is 2k. I half it, I get k. So I stick it there, square it, and subtract it off, right? Okay, so let's just get rid of that. Now let's simplify what we've got here. So I have got, go back to yellow. I have got -2 bracket x minus 1 all squared. Now -1 squared is +1, so we've got minus +1 like that, plus 3. And I'm just now going to expand this square bracket out. So I get -2 bracket x minus 1 all squared. -2 times -1 is +2 plus 3. And so this thing is going to become -2 bracket x minus 1 all squared plus 5. And that essentially is my answer. So the constant a, that thing there is 5. B is -2, and C is -1. Okay? All right, then. Let's have a look at part B. Hence, we want to write down the range of the function, right? So it's the same function where x has a domain of all the real numbers. Now, what does the range mean? The range is the set of all output values. And in this case, it's like the y values, the y coordinates, right? Whereas the domain is the set of all the input values, which is the x values, right? So domain is the x's and range is the y's. So how am I going to find out all the possible output values? Well, the best way really to do it is just to actually have an idea of what the sketch of this graph looks like, right? So we're just going to go back to here. What's this graph going to look like? Well, first of all, we know that this is going to be a negative quadratic, right? So we know it actually just by going up to here, right? This is a negative quadratic, and a negative quadratic is a sad-faced quadratic, right? It's going to look like that, right? So if we've got a negative quadratic, it's like that. If we've got a positive quadratic, it's going to be like that, okay? So we got a sad-faced quadratic. That's the first point. Second point is we know the vertex, because the vertex is going to be given by this coordinate here, right? Or rather the negative of that coordinate. So that would be x coordinate of 1 and y coordinate of 5, right? So the vertex is going to be the coordinate 1, 5. Now, just if you're not sure about that, if we've got the general case, if we've got the case y is equal to x minus m squared plus n, the vertex will be at the coordinate m, comma n, right? So you got to remember that this guy here needs to be the negative, which will often confuse people, right? So we treat it as x minus m gives us the x coordinate, and the n gives us the y coordinate. So if we know all of this, then what would our graph look like? Our graph is going to look something like this. We are going to have a vertex at x is equal to 1 and y is equal to 5. So 1, 2, 3, 4, 5, like that. 5. Right, so there's our vertex. And it's going to be a negative quadratic. So it's going to be going downwards like that. Yeah, sorry about that. Negative quadratic. So what are the y values that I can have? Well, basically, the y values are going to be 5 and everything below. Okay? Because I can't be anything higher than 5. So the range, in this case, the range is y is less than or equal to 5. Now, of course, you don't need to sketch it, right? And I'm sure that many of you are just able to get it, you know, just by observing, really. But I think, to be honest, the best way to always deal with domain and range is at least to be able to visualize in your mind what the graph looks like. Okay, and I encourage you to be very, very, very careful with this whole negative quadratic and positive quadratic thing, because I think a lot of people would have just said, oh, this thing here is a positive 5, therefore y must be greater than 5. And the reason they've done that is because they've ignored the fact that this is actually a negative quadratic. So actually the graph is flipped. Okay, so just a word of warning. And as I usually say, your primary goal, right, is not to be quick. It is first to be accurate. And then you can worry about being quick. Okay? All right. Question 3. Use algebra to show that this equation here has no real solutions. Well, basically, this guy is going to be a quadratic, isn't it? And to show that it's got no real solutions, we will need to show that the discriminant of the quadratic must be negative. So first of all, what I'm going to do is I'm going to try to simplify this quadratic. So I'm going to expand the bracket, which will give me 5x squared minus 15x is equal to 5x minus 26. And I'll bring it all to one side. So 5x squared, I subtract 5x from both sides, so I get negative 20x plus 26 is equal to 0. Now, we need to understand how the discriminant works. So the number of solutions is going to be determined by the discriminant. So sorry, let me just rewrite that again. So the discriminant is b squared minus 4ac, and number of solutions. Okay. And basically the discriminant can take one of 3 possible cases. Right? It can either be the case that the discriminant is positive, or it can be negative, or it can be 0. Right? Those are the 3 cases: positive, negative, or 0. Now, if the discriminant is positive, it means you have got 2 distinct solutions. Right? 2 distinct. It means that they're 2 different numbers, like 3 and 5, for example. If it is negative, it means you have got 0 solutions, or to be more precise, 0 real solutions. Okay, you do your A level, you find out what that means. Now, if the discriminant is 0, on the other hand, you have got 1 solution which is repeated, right? So you've got 1 repeated solution. For example, it will be 3 and 3, right? The number is the same. So there are 2 ways of thinking that, right? You can either say that it's 1 solution which is repeated, or it's 2 solutions which are the same. But I prefer to think of it as 1 solution which is repeated, because then, you know, you've got 0 solution, 1 solution, 2 solutions, which I think is easier to memorize. Now, why is that? For those of you who are wondering, well, it goes to the quadratic formula, right? Quadratic formula is minus b plus or minus the square root of b squared minus 4ac all upon 2a. So the discriminant is that thing there that's inside the square root. And if you think about it, if that guy is negative, then you can't square root a negative, which means you've got no solutions. Okay? If this thing here is 0, right, if it's 0, then what you're going to end up with is negative b plus 0 over 2a and negative b minus 0 over 2a. And that's the same thing, right? Right? Negative b plus 0 and negative b minus 0 is the same thing. So you get two solutions which are the same, or 1 solution which is repeated. Whereas if b squared minus 4ac is positive, then let's say it's 4, right? Positive 4. Then what you'd get is you get minus b plus 2 and minus b minus 2. And those two things are different. They're distinct roots, okay? So that's the explanation for what's going on, just in case any of you were sort of wondering why. Okay, so in this particular case, basically what we've got to do is we've got to calculate the discriminant. So b squared minus 4ac is equal to, so b squared is negative 20 all squared minus 4 times by a, which is 5, times by c, which is 26, okay? Well, negative 20 all squared is positive 400. 5 times by 4 is 20, isn't it? And 20 times by 26, okay, I can do 2 times by 26, which is 52, times by 10 is 520. So we've got negative 120, and lo and behold, the discriminant is negative, which means we've got no real solutions. So you should probably write something like, since b squared minus 4ac is negative, there are no real solutions. Okay, and that'll be your answer. Okay then, question 4. Find the exact distance between the 2 points where this curve cuts the y-axis. Well, okay, what do we know about where a curve cuts the y-axis? We know that at that point, x must be equal to 0. Okay, that's what we know. And if you've ever been unsure about that, right, it's always good to learn now. This guy here is the y-axis, right? This guy here is the y-axis. Let's imagine we take coordinates along the y-axis. This is the coordinate 0, 1. This is the coordinate 0, 2, 0, 3, 0, 4. We go down here, 0, negative 1, 0, negative 2, 0, negative 3. What do you notice? Along the y-axis, the x-coordinate is always 0. So if we want to find the y-intercept, it's the same thing as asking where is the x-coordinate 0, okay? All right, so I just thought I would just do that, just in case any of you were wondering. So y-intercept, when x is equal to 0. So we're going to substitute that into the curve here. So we're going to get 9 bracket 0 minus 1 squared plus 4 y minus 3 all squared is equal to 36. Okay, well, 0 minus negative 1 is negative 1, and negative 1 squared is positive 1. So this is 9 plus 4 bracket y minus 3 all squared is equal to 36. I am going to subtract 9 from both sides. So 4 bracket y minus 3 all squared is equal to 36 minus 9, which is 27. And I think I could expand, right, and then try to use the quadratic formula, but I think it's actually going to be easier to do it this way. So I'm going to do y minus 3 squared is equal to 27 upon 4. And then I'm going to square root both sides. So y minus 3 will be equal to plus or minus the square root of 27 upon 4. Now, this is going to be the same as plus or minus the square root of 27 over the square root of 4, and the square root of 4 is 2. Now, how can we simplify 27? 27, right, is equal to 9 times by 3. Okay, and so that is going to be equal to 3 root 3, because we square root the 9, we get 3. Now, remember, you can't use a calculator on this question because that's what you're told at the front. Now, what that means is you need to demonstrate your working. Okay, you need to demonstrate what you've done. So I would suggest that just to make sure that you do get the marks, you write something like, this is 9 times by 3 over 2, and therefore this is 3 root 3 plus or minus 3 root 3 upon 2. Okay, so if that's the case, then I just got to add 3 to both sides. So y is going to equal to 3, adding 3 to both sides, yet 3 plus or minus 3 root 3 upon 2. Well, then, if we're asked to find the distance between these 2 points, well, let's just think about what that's going to look like, right? Here we've got our Here we got our x-axis. Here we got our y-axis. Okay. And so on our y-axis, let's say this value here is 3. Well, either we're going to go up to 3 plus 3 root 3 upon 2, or we're going to go down to 3 minus 3 root 3 upon 2, right? But the point is the distance going up is the same as the distance going down, right? Which is 3 root 3 upon 2. So the total distance there, the distance, is just going to be equal to 3 root 3 upon 2 times by 2, which is 3 root 3. All right, so you could use the distance formula if you want, right? I mean, there's nothing stopping you, and you would get the right answer, but it just doesn't make a huge amount of sense, right? Because actually, if you just visualize it on the graph, then you should be able to calculate it relatively straightforwardly. Okay. All right, then part B of this question, we want to find the coordinates of the points where the curve with this equation here intersects this curve with the equation y equals 1 upon x. We want to give our answer in this form here, where a and b are rational and c is the smallest integer. Okay, well, basically what we've got to do is we've got to substitute that into this equation here. So let's just get on and do that. We're going to get 2x squared plus 83x times by 1 upon x is equal to x cubed times by 1 upon x minus 20x. And this is going to simplify, isn't it, right? Because x divided by x just cancels out, and x cubed divided by x, that will give us an x squared there. So if we simplify this, we get 2x squared plus 83 is equal to x squared minus 20x. Okay, and so just rearranging this a little bit will give us, I'm going to subtract x squared from both sides, so we get x squared here. I add 20x to both sides, so plus 20x plus 83. Now, because we know we're going to have to give this in surd form, we know that this isn't going to factorize, so we've got to use the quadratic formula. What is the quadratic formula? X is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So we just got to substitute that into here. So let's do that. We've got negative 20 plus or minus 20 squared, which is 400, minus 4 times by a, which is 1, times by c, which is 83. Okay. All divided through by 2a, so divided through by 2. Okay, so now let's try to simplify this. So we have got a half bracket negative 20 plus or minus the square root of, well, actually, I think what I'll do is I'll factorize out the 4 first. So 4 bracket 100 minus 83. Yeah. And if I do that, then what I'll get is I get negative 20 plus or minus 2, right? Because the square root of 4 is 2, and 100 minus 83 is 17. So I get 2 root 17. So now if I half that, I'm going to get negative 10 plus or minus root 17, I think. Now, what are we asked to find in the question? Find the coordinates of the points. All right, okay. So we've got two x coordinates. We have either got x is equal to negative 10 plus root 17, or we have got x is equal to negative 10 minus root 17. Now, in order to go on then, what we need to do is we need to find the y coordinates. Now, how do we find the y coordinates? The y coordinate is equal to 1 divided by x, right? So y is going to equal to 1 divided by negative 10 plus root 17. Or, in this case, y is equal to 1 divided by negative 10 minus root 17. Okay? Now, we need to rationalize this. So how are we going to rationalize? Well, for the one on the left, we're going to multiply the top and bottom by the conjugate, which is negative 10 minus root 17. And this means we've got to multiply the top by that as well. So negative 10 minus root 17. So let's do all that. So if you're wondering what's happened there, when we do the conjugate, right, if we've got a plus b on the denominator, we multiply by a minus b, okay? And the reason for that is the root 17, the third, will cancel off. So on the top, we will get negative 10 minus root 17. On the bottom, we get negative 10 times negative 10, which is positive 100. And negative 10 times by negative root 17 is going to be positive 10 root 17. And then root 17 times by negative 10 is negative 10 root 17. So those guys cancel off. And then we've got root 17 times by negative root 17. So we're going to get negative 17, right? Because root 17 times root 17 is just 17. So this guy here will be negative 10 minus root 17 over 83. Okay, that's the y coordinate. Let's just do it for this guy. Okay, so we just go across a little bit. Here, the conjugate will be negative 10 plus root 17. Negative 10 plus root 17. Okay, so again, if we multiply that, on the top we get negative 10 plus root 17 divided by negative 10 times negative 10 is positive 100. Again, the third term is going to cancel off, and we're going to get negative 17. So that will give us negative 10 plus root 17 over 83. Okay, now we just need to be aware of how they want the answers given. So give our answers in the form a plus b root c, where a and b are rational and c is the smallest integer. All right, so we've got coordinate. So we got our x coordinate as negative 10 plus root 17. So negative 10 plus root 17. And the y coordinate that gives that is negative 10 upon 83 minus 1 upon 83 root 17. So that's one of the coordinates. And the other coordinate is negative 10 minus root 17. And the y coordinate is going to be negative 10 upon 83, not minus, plus 1 upon 83 root 17. Okay, so that's writing it in the form that they've asked in the mark scheme, which is extremely irritating, but you just got to do what they say. Okay, and I've just checked the mark scheme, and I am right. Okay, so that's good. So I think that's an okay question. Just a little bit of patience. Hopefully you should be able to see your way through that. Okay, question 5, a combinations permutation style question. There are 3 women, 2 men, and 4 children in a choir. The choir stands in a single straight line. Find the number of possible arrangements if the first person and the last person are both women. Okay, now, with all of these questions, we need to determine whether or not we're using combinations or permutations. Okay, and the key to understanding that is NPR, the order matters. Okay, order matters. And with N, or 2 T's in matter, and with NCR, the order does not matter, right? So order does not matter. And if you want a clarification on that, right, what NPR actually means is it means the number of ways we can arrange R items taken from N items, whereas NCR means the number of ways we can choose R items taken from N items, right? So with combinations, there's no arrangement, so the order isn't important, but with permutations, we are arranging, so order does matter. So in this particular question, right, we just got to determine what circumstance we got. Well, if we're standing in a straight line, then the order matters, right? Because if we've got John, Paul, and George standing like that, well, if I was to rearrange them into a different order, George, Paul, and John, then that would actually be a different line, right? So I could have the same people, but in a different arrangement, that would count as a different line. So in this particular case, the order does matter. So we're using permutations. All right, now let's draw this guy out. We're going to have 9 people standing in a line. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Because 3 plus 2 plus 4. 3 plus 2 plus 4 is 9. And we require that the first and last person are women. Well, how could we do that? Well, how many ways could we choose the first person? 3, because there are 3 women to choose from. And how many ways could we choose the last person? 2, because we've already chosen 1 woman, so there are 2 women left. So now what we've got to do is we've got to choose the remaining 7 people in the middle. And the number of ways I could do that is 7 factorial, or if you prefer, 7p7. And the reason for that is we've got 7 people remaining and we're arranging 7 of them, so that's 7p7. So the total number of ways is going to be equal to 3 times by 7p7, which is the same thing as 7 factorial, times by 2. And why are we multiplying? Well, because we want a woman here, and we want the 7 people here, and we want another woman there. So whenever we've got an and, then we multiply, right? So we've got a woman here, and we've got the 7 people, and we've got the other woman at the end. So whenever we've got an and, we multiply. All right, so let me just crack that into the calculator. So I will do 7 factorial times by 6, which is 30240. 30240. I will just quickly check that against the mark scheme, which is 30240. Okay, so that's correct. Okay, next question. Find the number of possible arrangements if all the children stand next to each other. All right. Again, this is a fairly standard type of question, actually. Let's draw out the line. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many children we got? 4 children. So let's imagine we group up all the children here, right? So we've got 4 children. And we're going to kind of stick them together as one unit. So how many units have we got to arrange now? We've got 1, 2. This guy now counts as one whole thing. So that's 3 units. 4, 5, 6, right? So let's think of that again. We've got one person here, a second person. We're considering the group all as one thing. So that's 3, 4, 5, 6. So how many ways can I arrange those 6 items? 6p6 or 6 factorial. And then what we've got to do is we've got to look inside the group of children and say, how many ways can we rearrange those 4 children? Well, that would be 4p4 or 4 factorial. So ultimately, the number of ways is going to be 6 factorial times by 4 factorial. So 6 factorial times by 4 factorial, which is 17280. 17280. And again, I'll just check that. And that is correct. All right. Next, part B. 4 of the choir are selected to sing in a group. Okay, find the number of different selections if no man is chosen. Right, well, are we using permutations or combinations? Well, here, does the order matter or not? And I would suggest that in this case, it doesn't matter, right? If I've got John, Paul, George, and Ringo, like that, and I've chosen them to sing, then it doesn't matter if I chose them in a different order, Ringo, George, Paul, and John, it would still be the same 4 people that I've chosen. So in this particular case, the order is not important, right? I can switch these guys around and it's still the same 4 people, right? So we're using combinations because order doesn't matter. Okay, now if no man is chosen, how many men were there? There were 2 men, weren't there? Right? So if no man is chosen, how many people can we select from? Well, we had 9 people minus 2 people. So we've got 7 people that we can choose from. That is the 4 children and the 3 women. And we're selecting 4 of them. So the number of ways we could do that will be 7c4. Okay, so 7c4, let me just put that into the calculator. 7c4 is 35. Okay, again, I'll just double check that. Answer is 35. Yeah, answer is 35. Okay, next, 2. Find the number of different selections if at least 2 women are chosen. Okay, at least 2 women. Well, we had 3 women, didn't we? So if we have at least 2 women, we've either got 2 women and 2 others, or we've got 3 women and 1 other. So how many ways can we choose 2 women from 3 women? Well, that would be 3c2. And how many ways could we choose the 2 remaining others? Well, we've got 7 other. We've got 6 other people, isn't it? Right? Because 9 minus the 3 women gives us 6 women, 6 other people, 6 men and 6 children. Sorry, or 6 men or 6 children. Sorry, you know what I mean, right? There are 6 other people remaining, and I've got to choose 2 of them. So the way I can do that would be 6c2. Okay, now what I'm going to do with these is I'm going to multiply them. Why am I multiplying those two? Because I want the 2 women and the 2 others. So when I've got something and something else, I multiply. Well, the same thing is going to be true for the other situation, right, where I've got 3 women and 1 other. So how many ways can I choose 3 women from 3 women? It will be 3C3. And how many ways can I choose that 1 other person from the 6 potential people? Well, it would be 6C1. And I want the 3 women and this 1 other person, so I'm going to be multiplying these 2 together. Okay, so let's calculate what these are. So 3C2 is 3. 6C2 I think is 15. So 6C2 is 15. So 3 times by 15 is 45. And then 3C3 is 1. And 6C1 is 6. So now what do we do with these? Well, we're going to add them. Why are we going to add them? Because either we've got the first situation, 2 women and 2 others, or we've got the second situation, 3 women and 1 other. So when we've got 2 different circumstances, right? So A or B, then we need to add. So if we add those together, we will get 51. Okay. All right. So I think they're just being nice and systematic, and also understanding the difference between and or will probably go quite a long way. Okay. And 51 is the right answer. Good. All right, then question 6. Variables x and y are related such that y equals this. Use differentiation to find the approximate change in y as x increases from 3 to 3 plus h, where h is small. Okay, now, with a question like this, if you see approximate, you know that you need to use this form here. Delta y upon delta x is approximately the same as dy dx. Now, the thing is, a lot of students, I think, don't really understand what's going on here. So let me try to illustrate. Imagine that I've got a curve, okay? Now, this curve isn't the same as that curve, right? So I haven't drawn it accurately, but I just want to have some curve, okay? And let's say I've got 2 points. I've got the points A and I've got the point B, okay? And A has got an x coordinate of 3, and B is kind of a very little distance away from A, such that the distance in the x direction is a distance of h, right? So I go to 3 plus h here, right? So this little distance is a distance of h. Now, what we could do is we could find the gradient between the point A and B. So I would draw a line between A and B like that, something like that. Okay, and I would find the gradient of that line. Now, what would be the gradient of that line? Well, gradient is always given by the change in the y divided by the change in the x. Sorry, I just want to try to delete that. It's a bit annoying. The change in y over the change in x. So what could be the change in y? Well, we could call that thing delta y, right? Delta y just means a little change in y. And the change in x we can call delta x, a little change in x. Okay, so the gradient of the red line, so the gradient of the red line, the line AB, is equal to delta y over delta x. But now let's say I was to draw another line, a green line, which is the tangent to the curve at A. Right, so that line there, the green line, is the tangent, beg your pardon, is the tangent at A. And the fancy way of writing that is to say it is dy dx calculated where x is equal to 3. Okay, so this notation here means dy dx tells us the gradient, and we've calculated the gradient at the point where x is equal to 3. Now, if point B is pretty close to A, in other words, if this little distance here is very, very small, then what we are saying is the gradient of the red line, delta y upon delta x, is basically the same, or very, very close to, the gradient of the green line, right, which is the tangent. So hence, that's why we end up with this formula here. Delta y upon delta x is approximately the same thing as dy dx, the gradient of the tangent. Okay? So what have we got to do in this question? Basically, we need to find out the dy dx of this, right? We want to find the gradient of the tangent when x is equal to 3. Okay, so first job is we've got to differentiate this guy. we've got two functions multiplied, right? One function is cos x, the other function is sine x all squared. So if we've got the product of two functions, we need to use the product rule. So we're gonna go down now and do that. So u is equal to cos x. V is equal to sine x all squared. Now I've written it like that because it's going to help me to understand the chain rule that I've got to use later on. Okay, now if I differentiate u, cos x will differentiate to give negative sine x. If I differentiate v, right, now what I got to remember is I've got the sine x inside the bigger function of the x squared. So I need to use a chain rule here, and the way I do that is I differentiate the big function first. So I differentiate the x squared. So I get 2 bracket to the power 1, right? So I've done that. Then what I do is I take the function on the inside, the sine x, I differentiate that, which gives me cos x, and I multiply through. So just to reiterate, we got a chain rule here because we've got a sine x, one function inside of the other function, x squared. And so the way to do that is you differentiate the big function first, right? So power comes down to front, reduce the power by 1. Then you differentiate the little function on the inside, sine x, you multiply through. Okay, so now that we got that, we've got to remember what is the product rule. Product rule is v du plus u dv. So I just got to substitute this all in. So v is sine x all squared times by u prime, which is negative sine x, plus u, which is cos x, times by v prime, which is 2 sine x cos x. Okay, well let's see if we can simplify this all out. This is going to be negative sine x cubed, isn't it? Negative sine cubed x plus 2 lots of cos x times by sine x. Okay. All right, so that's my dy dx. Sorry, beg your pardon, that's not y, it's dy dx y prime. Okay, so now what I want to do is I want to calculate that when x is 3. So I need to calculate dy dx at the point where x is equal to 3. And so I've got to substitute 3 into here. So I'm going to get negative sine 3 all cubed plus 2 cos 3 times by sine 3. Now, guys, this must be in radians, right? Now, there's a reason for that. The reason is essentially that differentiation and integration only work in radians, right, if you're using sine, cos, and tan. And the reason for that is that the proofs for differentiating sine and cos require the use of radians. So you never actually have a choice, right? You never have the situation where you go, oh, okay, you know, I can use degrees here. Maybe I could use radians. No, you must use radians if you're doing any differentiation or integration. Okay, so you want to change your calculator to being in a radians mode. And I would actually encourage you, as soon as you read a question like this, you actually change your calculator mode before you even start the question. Okay, because otherwise midway through you will forget. Right, so let me try to calculate also negative open bracket sine of 3 close bracket to the power of 3 plus 2 cosine 3 close bracket. Oh, sorry, I omitted the cos squared, isn't it? I realize I'm such an idiot. Do beg your pardon, guys. Sorry about that. Got to go back. So 2 bracket cosine 3 close bracket all squared times by sine 3. Right, now if I do that, I get 0.274. So if I do that, I get 0.274. Okay. I can't remember if they want it to 3 significant figures or 2 decimal places or whatever, but I'll just leave it like that for the time being. Now, what did we say? We said that delta y over delta x is approximately equal to dy dx when x is equal to 3, so that's equal to 0.274. Well, in this question, what is our delta x? What is our small increase in x? It's h, isn't it, right? H is the small increase in x. So I can replace the delta y with h, like that. That's h. And so therefore delta y, the small increase in y, is approximately equal to 0.274 times by h. Now I'm just going to check the mark scheme, see if I'm right about that. Let's go through. Yeah, 0.274h. Okay. All right. Sorry, just one other thing. Because I don't have a huge amount of time, so usually if I make a mistake, I'll go back and I'll re-record it. But I think actually in a way it's quite a helpful thing. You are human, right? You are going to make mistakes. And particularly in a 2-hour exam, as you go through it, you are going to misread your own writing. You're going to skip over something. That's just the way it is, right? So if I was doing this exam, I wouldn't get 100% because I make small errors just like this all the time. However, there are things you can do to help yourself. And the best strategy, I think, if you're the kind of guy who's aiming for your A star, you go through the paper and really you should be close to finishing the paper after about an hour and 15 minutes. What you then do is you ask the invigilator for blank sheets of paper and you go through the questions again. If you go through your paper and you're looking at your own working, you cannot spot your mistakes, right? It's just part of human nature. It's very difficult to spot your mistakes. If you do it again completely from scratch, you can compare your answers that you got first time and second time. And if the answer is the same both times, then you're pretty confident that you're right. If it's different, then it's likely that you've made a mistake, right? Either in your first attempt or in your second attempt. And that means you've got a mechanism to go back and check very thoroughly. All right, so that's my recommendation to you. I think I was very, very lucky that I just caught my eye here a moment ago, and I was able to notice that I'd made a mistake. Okay. All right. Okay, here we are in question 7. It is given that y is equal to this thing here, where m and n are non-zero constants. It is also given that 3 times by the second derivative is equal to the first derivative all squared minus y for all values of x. Find the values of m and n. Okay. This looks slightly unusual, but in a way, I don't think it should actually be that difficult. Essentially, what we need to do is we need to differentiate this function twice and substitute it into here. So let's write that out. So y is equal to mx squared plus a half x plus n. So the first derivative, if I differentiate mx squared, I'll get 2mx. And if I differentiate a half x, I get a half. And then for the second derivative, if I differentiate, I will get 2m. So now what I need to do is I just need to substitute into the equation at the top, so into here. So 3 times by the second derivative, 3 times by 2m, is equal to the first derivative, which is 2mx plus a half, all squared minus y, which is mx squared plus a half x plus n. And really, this is actually strictly speaking an identity because you're told that it's true for all values of x, right? So you're not really trying to solve to find x. If a statement is true for all values of x, and this is an identity, so actually I'm going to change that to say we've got 3 lines here, which means that the left-hand side is always going to be equal to the right-hand side. Okay, now I'm going to expand this and try to simplify it a little bit. So on the left-hand side, we have got 6m. On the right-hand side, if I expand the bracket, we'll get 2mx all squared, which is 4m squared x squared. 2mx times by a half is mx, but I've got 2 of them, so that's 2mx. And then I've got a half squared is a quarter. Ooh, a quarter there, sorry. I'm going to rewrite that so it's not so messy. A quarter. And minus mx squared minus a half x minus n. And I should collect the terms on the right-hand side. So I want to get the terms which are the x squared terms, which are this term here and that term there. So I end up with bracket 4m squared minus m x squared. I'm just going to cross those off to make sure that I have got every term. And then I'm going to get the x terms, which are this term here and that term there. So that will be plus 2m minus a half x, right? So I'll cross off those terms as well, gone and gone. And then the constant that I've got is a quarter minus n, so plus a quarter minus n, right? So I've simplified the right-hand side. Now on the left-hand side, I should really try to simplify it as well. But what I'm going to do is I'm going to include the x and the x squared terms, which are kind of hidden. So in other words, on the left-hand side, I've got 0x squared plus 0x plus 6m, right? So that's what I've got. Now remember that this is an identity, isn't it? So what we're saying is, we're saying that the left-hand side is always the same as the right-hand side. And because that's the case, we can compare the coefficients. We can compare the coefficients of x squared. So if I compare the coefficient of x squared, those should always be the same. If I compare the coefficient of x, those should always be the same. And if I compare the constant term at the end, those should always be the same. Okay, so that's really the key to doing this, is basically to recognize actually it's an identity. So comparing, if I compare the x squared terms, then I'm going to get 0 is equal to 4m squared minus m. And that will give us, all right, and if that's the case, then I can factorize this guy. So that will give me m bracket 4m minus 1 is equal to 0, which means either m is equal to 0 or m is equal to a quarter. Now, were we told in the question, m and n are non-zero constants, isn't it, right? So m must be equal to a quarter. In other words, we've got to reject m is equal to 0. Okay, and then we could compare the coefficients of x, which would give us 0 is equal to 2m minus a half, which means that 2m will be equal to half, which again means that m is equal to a quarter. Okay, so that's the same. And then we can compare the constant term, so 6m, so the constant, 6m is equal to, what was it? A quarter minus n. So a quarter minus n. So m is a quarter, right? So we've got 6 quarters there is equal to a quarter minus n. So if I subtract a quarter from both sides, 5 quarters would equal to negative n, and therefore n must be equal to negative 5 quarters. So I think I've got the answer there. So m is a quarter, n is negative 5 quarters. Let me just check against the mark scheme. So where is it? M is a quarter, n is negative 5 quarters, and no other values. Okay. All right then, question 8. In an arithmetic progression, the sum of the first 30 terms is negative 1065. The sum of the next 20 terms is negative 2210. We want to find the first term and the common difference. All right. Well then, we need to know the formula, first of all, for the sum of the first n terms. The sum of the first n terms is n upon 2, 2a plus n minus 1d, right? That's the first thing. And the second thing is we need to really understand what's going on in the question as a whole. So we've got the first 30 terms, right? So u1, u2, u3, u4, and so on, all the way up to u29 and u30, right? And so that will be the sum of the first 30 terms, right? That guy there. Okay, so if I added up all of those, that would be S30. But we're also asked to find the sum of the next 20 terms. So if we imagined it carrying on, we got u31, the 31st term, u32, 32nd term, all the way up to u50, right? And so this thing here is what we're asked to find, the sum of the next 20 terms. Well, how could we do that? Well, what we could do is we could find the sum of the first 50 terms, which would be that guy there. So we add up all of those. So that would be S50. And then we subtract away from that the sum of the first 30 terms, right? So if we do the sum of the first 50 minus the sum of the first 30, we're going to be left with the thing that we want, which is the sum of the next 20 terms. Okay, so now effectively all we've got to do is just got to substitute into the formula. So sum of the first 30 terms. S30 is 30 upon 2, 15. So sum of the first 30 terms is 15 times by 2a plus n minus 1, so that's 29 times by d. And we know that that is equal to negative 1065. So I can just write that there, negative 1065. And I think that I can divide that through by 15 in order to simplify. So 1065 divided through by 15 is 71. So this guy I can write as negative 71 is equal to 2a plus 29d. Okay, so I get that equation there. And then if I want to find this kind of the bit in green, right? So I do the sum of the first 50 terms minus the sum of the first 30 terms. And the sum of the first 50 terms, I'll just use the formula. So 50 upon 2 is 25. 2a plus n minus 1, so that's 49d. And we know already that the sum of the first 30 terms is negative 1065, right? Because we're told that in the question. So this is minus 1065, right? Because that is the sum of the first 30 terms. And we are told that this difference is equal to negative 2210. All right, so I'll write that there. This is equal to negative 2210 is equal to 25 times by 2a plus 49d minus, so that's plus 1065. Okay, so now I've just got to rearrange a little bit. So I've got to do 2210, or sorry, negative 2210 minus 1065. And if I do that, I get 3275. So 3275 is equal to 25 bracket 2a plus 49d. And I'm going to divide that through by 25. Sorry, that should be a negative there, beg your pardon. So that will give me negative 131 is equal to 2a plus 49d. Okay, all right, so it looks to me like I've got two equations. I've got this equation here, equation 1 I'll call it, and this equation here, equation 2. I've got two equations and two unknowns, which is simultaneous equations. So let me just rewrite it in a way that hopefully makes it easier to see. 2a plus 49d is equal to negative 131, and 2a plus 29d, 2a plus 29d is equal to negative 71. Was that right? Yeah, negative 71. Okay, well, if we were to subtract the bottom equation from the top, then we get 2a minus 2a, which is 0, 49d minus 29d, which is 20d. And then we've got here negative 131 minus, so that's plus 71. And that will give me negative 60. So therefore, d is going to equal to negative 3. And of course, if we've got d is equal to negative 3, we can substitute in to, let's say, the second equation. So 2a plus 29 times by negative 3 is equal to negative 71. 29 times by negative 3, well, 30 times by 3 is 90, isn't it? And then add another 3, or minus another 3 is 87. So that'd be minus 87 is equal to minus 71. So I'm going to add 87 to both sides. So 87 minus 71 is 16. And so A is equal to 8. Okay. And I think that's all we were asked to do. Yeah, just find first term and common difference, find A and find D. So I get A is 8 and D is negative 3. I'm just going to check that against the mark scheme. Yeah, that is correct. Okay, so I think that's a slightly tricky question, but as long as you're, you know, careful and patient with your algebra, I think it should be okay. All right. Okay, question B. A geometric progression is such that the first term is 4 and the sum of the first 3 terms is 7. Find the 2 possible values for the common ratio and find the sum to infinity for the convergent progression. Well, we could use the formulas, but I suspect the formulas will take us a little bit longer actually, right? What are the first 3 terms? We got 4, and then the next term will be 4 times by the common ratio, so that's 4r. And the next term after that will be 4r times by r, right? So 4r r squared. So the sum of the first 3 terms is just going to be those 3 things added up, right? So I think I'll just do that. So I'll do 4 plus 4r plus 4r squared is going to be equal to 7. Okay, and that means that I'm going to get 4r squared plus 4r minus 3 is equal to 0. And that's a quadratic, isn't it? So I'll try to factorize it. I'll try with 4r and r first. Let's see if that will work. And that would mean I would have to have a 3 and 1, wouldn't it? So would that work? No, probably not. So let's try 2 and 2r and 2r. So 2r, 2r, 3 and 1. So plus 3 minus 1, I think that would work, because if I do that, negative 1 times by positive 3 is negative 3. 2r times by 3 is 6r. Negative 1 times by 2r is negative 2r, so 6r minus 2r is 4r. Okay, so that works. So I would get 2 possible values for r, which would be r is equal to a half, and r is equal to negative 3 upon 2. Okay, so that's the first part. Find the sum to infinity for the convergent progression. Well, look, for a convergent progression, what we require is that the common ratio must be between negative 1 and positive 1 for convergence. Now, why is that? Convergence basically means that the terms are getting smaller and smaller and smaller. So if I was to imagine, for example, let's say this series, so I'll do it in blue. Let's say we had 9, 3, 1, a third, a ninth, right? And what's happening there is the common ratio is a third, right? Because we're dividing by 3 each time. And as this progression carries on, it's getting smaller and smaller and smaller. So actually the terms are going to approach 0 eventually. How can this happen? Well, it can only happen if the common ratio, the thing that you're multiplying by, is less than 1. Or rather, to be more precise, between negative 1 and positive 1. Because if it's any value where the magnitude is greater than 1, then the terms are going to grow. And so instead of having convergence, you're actually going to have divergence. The terms are going to get bigger and bigger and bigger, basically. So we need to ask ourselves the question, which of these 2 common ratios will it be? Well, that guy is the magnitude of that, so it's negative 1.5, right? So the magnitude is 1.5, so it's out of this boundary here. The terms will grow, whereas this is within the boundary, so the terms will get smaller. So essentially what we've got is we've got our first term a is equal to 4, and for convergence, r is must be the half value. Yeah, and so therefore we use the sum to infinity formula, which is a over 1 minus r. So we're going to get 4 over 1 minus a half, and 1 minus a half is a half, and 4 divided by a half is 8. Okay, so I get the answer there as 8. Let me just check the mark scheme. So, yeah, those answers are correct. Right, question 9. This is a functions question. Now, before I start, I recorded another video in, I think, May or June of this year, where I just went through lots and lots of these types of questions because I noticed they've become a bit more prominent in recent years, and often students struggle to answer them because they're more conceptual and you have to explain something. So I recommend watching that video because I go through many examples of that. In this particular question, we've got these 2 functions, f and g, and they've both got domains where x is negative, right? X must be less than 0. We've got to explain why the function fg does not exist. Now what does fg mean? Fg means the following. We are finding f of g of x. In other words, we're taking the function g and we're putting it into f of x, right? So we're going to take this function 1 upon x squared and we're going to put it into this function f. Now, another way to think about that is kind of with this diagram here. Let's say we've got the input x. The input x first goes in to the function g, and then the output of that goes into the function f. Okay, and that's how we get our full thing, right? So this whole thing represents fg, right? That's fg, right? First goes into the function g, then goes into the function f. All right. Well, we need to pay attention to the domains of these functions. Now, g has a domain that x is less than 0, right? So in other words, the values that go in must be negative, okay? And the same is true of f, right? The inputs to f must also be negative. But if we think about that just for a second, right? If the input to g is negative, then what's going to happen in g? We're going to get 1 divided by a negative number squared. Well, a negative number squared is a positive number, and 1 divided by a positive number is a positive. So actually the output here, instead of being negative, which is what we want, is going to be positive, right? So in other words, the outputs to the function of g are positive, but the inputs to the function f are required to be negative, right? So g is not giving the outputs that we need to go into f. So you need to say something like, since the outputs of g, or the range of g are positive, right? So if you want to write that, you can say g is greater than 0, right? They cannot be, it cannot be input into f, right? Since the domain of f, is negative, right? Or everything that's less than 0, right? So some kind of statement to the effect that the outputs of the function g are positive and the inputs to f are required to be negative, and so therefore that's why the function of fg cannot exist. All right, part B. Given that the function gf does exist, find and simplify an expression for gf. Well, what does gf mean? It means g of f of x, which is we take the function f of x and we stick it into g. So what's f of x? 3x squared over 4x minus 1. And what's the function g? It's 1 upon x squared. So we're going to take the function f and we're going to stick it into here. So we are going to get 1 over the function f all squared. And what is the function f? 3x squared over 4x minus 1. 3x squared over 4x minus 1. Well, that's the same thing as 1 over 9x to the power of 4 over 4x minus 1 squared. And that's going to be the same as 4x minus 1 all squared over 9x to the power of 4, right? Because if you're not sure, 1 divided by a over b is just equal to b upon a. We flip the fraction. And the way that works is we multiply top and bottom by b. Okay? All right, so I think that should be our answer there. Let me just double check the mark scheme. It's always good just to keep a check. And yeah, that's all right. Okay, then the next part C, show that f inverse can be rewritten as this. Oh dear, where p, q, and r are integers. Okay, well, again, in the long video, I go into this in a bit more depth, but basically what is an inverse function? We have an original function, f, and that takes in inputs, which we'll call x, and it gives out outputs, which we'll call y. What is the job of the inverse function? The inverse function is designed to take us from those outputs y back to our original inputs x. So for example, if we had an input of 2 into our original function and it gives us an output of 5, then what should the inverse function do? It should take the input of 5 and get us back to 2. Okay, so inverse function reverses inputs and outputs. That's kind of the job. So if we've got the function f, which is 3x squared over 4x minus 1, so we'll write that as y is equal to 3x squared over 4x minus 1. Then basically what we're trying to do is we're trying to rearrange this to make x the subject, right? To make the input the subject. So we get the input in terms of the outputs, y. So the way I'm going to do that is I'm going to rearrange. So I'm going to get y times by 4x minus 1 is equal to 3x squared. So this is 4y times by x. Write that a little bit neater, I think. 4y times by x minus y is equal to 3x squared. And with a little bit of rearranging, that becomes 3x squared minus 4y, lots of x, plus y. And the thing that I want to show you is that this is actually a quadratic, right? It's quite sneaky, this. This is our a term. So a is equal to 3. This here is our b term. So b is equal to negative 4y. And this guy here is our c term. So c is equal to y. So what we can do is we can solve the quadratic to find x by using the quadratic formula. So x is going to equal to minus b. So it's minus 4y, which is 4y, plus or minus the square root of b squared, so that's going to be 16y squared, minus 4 times by a, which is 3, times by c, which is y. And this is all going to be divided by 2a, so dividing through by 6. Okay, now we just got to tidy this up, basically. If we tidy this up, we are going to get x is equal to a sixth of, big bracket, 4y plus or minus the square root of 16y squared minus 12y. We can factorize out the 4, so we're going to get a sixth bracket 4y plus or minus the square root of 4. Actually, we can factorize out 4y, can't we? So factorize out 4y, we get 4y minus 3 there, close bracket. And we can square root the 4 to get 2. So we're going to get a sixth of bracket 4y plus or minus 2, the square root of y bracket 4y minus 3. Close bracket, close bracket. So now if we multiply through by a sixth, well, we can cancel off, can't we? So that will become a third of 2y plus or minus the square root of 4y minus 3. Okay? And that means we can now write our inverse function f inverse of x as being equal to a third of 2x plus or minus the square root of 4x minus 3, because in the end, I just replaced the y with the x, right? Because we defined the inputs, the inverse function as being x as well. Now, we've got to think about this whole plus or minus thing, I think. And the way we think about that is we've got to make an appeal to the domain and the range. Okay, so let's go back up to the original diagram. Okay, so what's the domain of a function? The domain is the set of all the inputs. So the domain is the set of all the inputs of a function. And what's the range? The range is the set of all the outputs of the function. Right, so what we've got here is the inputs to f are the domain and the outputs to f are the range. Now, we can do the same thing for the inverse function, can't we? We can say that the domain of the inverse function is all the inputs that can go into it, and the range of the inverse function is all of the outputs that come out of it. But hang on, the set of outputs for the original function for f must be the same as the set of inputs for the inverse function, right? So in other words, the range of f must be the same as the domain of f inverse. And likewise, the range of f inverse, the set of outputs of the inverse function, must be the same as the inputs to the original function. Why? Because the whole job of the inverse function is to take me from my outputs back to my set of original inputs. Now, we are told in the question that the domain of f
is x is less than 0. In other words, the domain is all these negative values. So what does that mean? It means that the range of the inverse function must also be negative. So we can go down here and we can say, hang on, we know that f inverse must be negative, right? Or the range of f inverse is negative, has to be negative, because it's the same as the domain, right? So since domain of f is negative, right? So you want to write some explanation. You want to justify your answer. So that means that this cannot be the positive square root, right? Because if it's the positive square root, then what's going to happen is we're going to get positive values of this inverse function. So what we actually got to have is got to have negatives. So therefore, actually, it's the case that f inverse of x is equal to a third of 2x minus the square root of, oh, beg your pardon, there's an x there, isn't it? Of x bracket 4x minus 3. Okay. All right, now let me just double check that answer, see if that's all okay. 2x minus the square root of x bracket 4x minus 3 upon 3. Yeah, that's the right answer. And yes, there is a mark for justifying the square root. Okay, so you need to make a statement like the one that I've done of some kind. Now, these questions are very hard. I think they're probably actually the hardest questions that I see so far. But what I recommend is you go through that long video of mine, and I'll give you all the explanations. Okay, question 10. We want to show that tan x plus sec x all squared can be written as 1 plus sine x over 1 minus sine x. So this is a trigonometric identity question. Now, there are a couple of different strategies you can do with this, but particularly when I notice that the end result has just got sines, then my strategy is immediately to convert things like tan x and sec x to sine or cos if I can. Now, if you watch another video that I've done, I also tend to do one other thing, which is I say this: let s equal sine x and c equal cos x. And the reason I do that is because I think if there's just so much writing on the page, it actually prevents you from seeing what you should do. So I like to simplify everything. I use S and C because I think it makes it easy to visualize. All right, so let's talk about the left-hand side, by which I mean this thing here, tan x plus sec x all squared. I'm going to write tan as sine divided by cos, so S divided by C. And I'm going to write sec as 1 divided by cos, so 1 upon c all squared. How do I know sec is 1 divided by cos? We always look at the third letter, 1, 2, 3. The third letter is c, so c is cos, right? So 1 divided by cos. Okay, then this guy I can simplify. I can write this as sine plus 1 over cos all squared, because the fractions have got the same denominator. And so then I can square this whole thing. So on the top, I'm going to get sine plus 1 all squared divided through by cos squared. And remember that what I'm aiming for is an expression just with sines in it. So I don't want a cos. So what I can do is I can replace that cos squared with 1 minus sine squared. Right? So on the top, I get sine plus 1 all squared. On the bottom, 1 minus sine squared. Now, why is that? Well, basically, because there are two core identities that you need to know. One we've already used actually in this question. So tan theta is equal to sine theta over cos theta. That's kind of basically one of the most essential identities. And the other identity you need to know is sine squared theta plus cos squared theta is identically equal to 1, okay? And so therefore, cos squared can be written as 1 minus sine squared, and sine squared can be written as 1 minus cos squared, okay? Now, why is this helpful? Because, firstly, we can write the 1 minus sine squared as 1 minus sine times by 1 plus sine. In other words, we can do the difference of two squares. So this identity here, a squared minus b squared, is equal to a plus b times a minus b is a very frequently occurring trick in these identity questions. So it's really worth memorizing. Now, why is that helpful? Because, well, sine plus 1, right, on the numerator, we can rewrite that as 1 plus sine. So it's just the same thing, right? So 1 plus sine squared. And what you should notice on top and bottom is that we have got a 1 plus sine and a 1 plus sine. So we can divide through by 1 plus sine. So it will cancel off. So what we're left with is 1 plus sine on the top. So 1 plus sine x, all divided through by 1 minus sine x. And that is the identity that we are asked to show. All right, then part B, hence we want to solve this equation, tan 3 theta plus sec 3 theta all squared is equal to 6 between 0 and 180 degrees. Now the key word here is the word hence. In other words, we've got to use the identity. And hopefully what you notice is that what our expression can be replaced with 1 plus sine over 1 minus sine. So first of all, I always use a substitution. So I say let u is equal to 3 theta. So we change the problem into tan u plus sec u all squared is equal to 6. And we said that that was 1 plus sine over 1 minus sine. So we've got 1 plus sine u over 1 minus sine u is equal to 6. So a bit of rearranging, 1 plus sine u is equal to 6 minus 6 sine u. And that will be 7 sine u is equal to 5. And hence we're trying to solve sine u. Sine u is equal to 5/7. Okay. Now, with all these other questions, hopefully one of the things you notice is I've also talked about how we do the substitution also for the domain because we basically take a question in terms of theta and we turn it into a question in terms of u, but that also means we need to do the same with the domain. We want to know what range of values for u we want to find. So if u is equal to 3 theta, that means that theta is equal to u divided by 3. And so instead of a domain of theta being between 0 and 180, we can replace that theta with u divided by 3. So we've got a domain that u divided by 3 must be between 0 and 180, which means that u must be between 0 and 540. In other words, what I've done is I have just multiplied everything through by 3 there. So basically, we are now trying to solve this equation, sine u is equal to 5/7, within this domain of u being between 0 and 540. Now, of course, what we could do is we could use the circle method, quadrant method. I think in the last couple of videos, I've used the graph, and I think in this question as well, the graph to me is actually the easier way to do it. But you know, different people, think about things differently. So if you're not a graph person, I respect that. That's totally fine. But I personally think it's the better way here. Okay, so this will be 180. That's 360. That's 540. What does a sine wave look like? Sine wave kind of goes up from like that, up to the maximum at 90 degrees, comes back down like that. It's going to go down there at 270 to -1, and come back up to 360 and complete the wave. And then we're going to have another going up like that and coming down like that. All right, sorry it's a bit rough. Okay, so that's the graph of sine u. Now we want to find where sine u is equal to 5/7, which means that we're trying to find where our curve cuts the line y equals 5/7. Okay, well, it's going to cut it here, 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 and here. So we're going to have 4 intersection points. And we can find the first of those by using our calculator. So we do the sine inverse of 5/7. So you've got to make sure your calculator is set to degree mode. Okay, so sine inverse 5/7. And I get 45.58. Okay, so 45.58. I'll just keep it in 2 decimal places for the time being. Okay. Okay, and then what will the next value be? This value here. Well, we can do it via symmetry because effectively what I'm saying is that 90 degrees is a line of symmetry. So this point is symmetrical with that point. And also this point here, 0 degrees, is symmetrical with this point, 180. So this distance, the 45.58 from 0 up to there, has got to be the same as that distance from 180 to our second point, right? So if we want to find this point here, it's going to be 180 minus the 45.58. Okay, so we do 180 minus 45.58, which will give us a value of 134.42. Okay. All right. Now, how can we get the subsequent values? Well, this value here is basically the same as this value, but it's just one whole wave along, right? So we go from here, we move one full wave to the right, then we're going to get to that point. So that's going to be an extra 360 degrees. Okay, so if I do that, so I'm going to calculate my point again. Okay, and I add 360 degrees, I get 405.58. So that value there is 405.58. And then I can do the same thing with this point here, right? This point, if I add 360, will bring me to that point there because it's another wave along. Okay, so 134.42 plus 360 is equal to 494.42. So 494.42. Now, of course, those are the solutions for u, isn't it, right? So we've got our solutions for u. U is equal to 45.58 and 134.42 and 405.58 and 494.42, okay, all in degrees. And we want solutions for theta, isn't it? Well, how do we get to theta? Theta is equal to 1/3 of u, okay? So we've just got to divide each of these guys through by 3. Okay, so 45.58 divided by 3 is 15.19, so I'll write it as 15.2 because I think it's to 1 decimal place. 134.42 divided by 3 is 44.8 degrees. Okay, 405.58 divided by 3 is 135.2. And 494.42 divided by 3 is 164.8. 164.8. Well, I think it's probably a good idea if I just check those answers against the mark scheme. So let me just do that. So where are we? 15.2, 44.8, 135.2 and 164.8. Those are all the correct answers according to the mark scheme. Now, as I say on all the other videos, right, I can completely understand why people won't want to use the method that I do. It is long, it seems convoluted, and you can probably do it faster using your quadrant method or whatever. But as I always say, my aim is not really to be fast so much as it is to be accurate. And the method that I use with the substitution, I'm basically pretty close to 100% confident that I will be accurate. Right then, question 11. The diagram shows a rectangle ABCD, so this thing here, where the length BC is equal to x. The area of the rectangle is 400. Two identical quarter circles of radius x by 2 are half x, so that's a half of that whole length there, are removed from the rectangle to make the shaded shape. Given that x can vary, find the value of x that gives the minimum value of the perimeter of the shaded shape, and hence find this minimum value. All right then. I think the first thing we want to do is we want to use this information here. The area of the rectangle is 400 centimeters squared. Now we already know one side length of this rectangle. One side length is given by x. but we're not told about the other side length. So I'm just going to label that. I'm going to call that guy y for the time being. Okay, so that guy will be called y. And therefore the area, which is x times by y, will be equal to 400. So let's write that down. 400 is equal to x times by y, and therefore we can write that and say y is equal to 400 divided by x. So that's kind of the first thing that I want to do. Then I think what I want to do is I want to get an expression for the perimeter. So how could I do that? Well, I've got this length here and that length there are identical. And what's that length going to be? It's going to be y minus the half x. Okay, so if I was to write that down for the perimeter P, I've got y minus a half x, but I've got two of those on top and bottom, so I've got to multiply by 2. Now over here, I've also got these lengths, right? I've got that length there and that length there, and both of them are equal to a half x, right? Because this is x, this is a half x, so what's remaining is also a half. So I've got two side lengths, each with a half x, like that. And then lastly, I've got this arc length, so this thing here, right? And what's the formula for the length of an arc? The formula for the length of arc is S is equal to R theta. Now, what is the radius here? The radius is a half x. And what's the angle? The angle is pi by 2 radians, right? I need to remember it's pi by 2 radians. So I have got two lots of, beg your pardon, to change it back to yellow, plus 2 lots of r, which is a half x, times by theta, which is pi by 2. Now, I think we can probably expand all this. So let's expand it. So I'm going to get 2y minus x plus x, yeah, plus a half pi x, right? Because a half times a half, there's a quarter, times by 2 brings me back to a half, okay? And if I was to tidy that up, well, we've got minus x plus x, so that disappears, that disappears. So I'm left with here 2y plus a half pi x. Now, we already know that y is equal to 400 divided by x, so I can now replace that here. So we've got 2 times by 400 divided by x plus a half pi x. And so that is 800 upon x plus a half pi x, right? So that's the function that tells me the perimeter of my shape. But we're told that the value of x can vary. So we want to find the value of x that gives the minimum value for the perimeter. Now, when do we get a minimum value? Well, it's a minimum value is an example of a stationary point. So it's where the derivative is equal to 0, right? Where dp dx is equal to 0. So let's write that down. The minimum is when dp dx is equal to 0. Okay, so what we've got to do is we've got to differentiate this function with respect to x and then set it equal to 0. So p is equal to 800 x to the power of negative 1. So I'm converting it first to indices form, plus a half pi x. So now if I differentiate, so I get dp dx is equal to negative 800 x to the power of negative 2, right? So bring the negative 1 to the front and multiply, which gives me negative 800, and then I subtract 1 from the power, which gives me negative 2. And then if I differentiate a half pi x, I just get a half pi, or pi by 2, right? Because if you think about it, that's like x to the power 1. Bring the 1 to the front and multiply. I then subtract 1 from the power, I get x to the power 0, and x to the power 0 is just 1. Okay, now let's try to simplify this. So dp dx is equal to 0, which means we'll get 0 is equal to negative 800 x to the power of negative 2, which is the same as negative 800 upon x squared, plus pi by 2. So if I was to rearrange that, that gives me 800 upon x squared is equal to pi by 2. Okay, I'm going to multiply both sides by x squared. So 800 is equal to pi by 2 times by x squared. Now times both sides by 2 and divide by pi. So 1600 divided by pi is equal to x squared. And so x is going to equal to the square root of 1600 over pi. Now, we can simplify that, right? Because the top is 16 times by 100. Yeah. And if we square root that over the square root of pi, well, the square root of 16 is 4, and the square root of 100 is 10. So the top is going to be 40 over the square root of pi. Now let's go up to the top. We just want to find the value of x that gives the minimum value, and hence find that minimum value. All right, well, we say it's 40 upon root pi. I suppose, strictly speaking, if we want to give it exactly, we'd have to rationalize, right? So that'd be 40 root pi upon pi. Okay, but I think they'll want the decimal value, so I'll just do that. So 40 divided by the square root of pi is equal to 22.6. Okay, so $22.6. Okay. And then we want to find the value of that p. So we just got to substitute into here. So I'll say when x is equal to 40 over root pi, we just substitute into the expression for p. So we get p is equal to 800 divided by x, so divided by 40 upon root pi, plus a half pi times by x, which is 40 upon root pi. So what I've done is I've stored that value in my answer of the calculator. So now I'm just going to type 800 divided by answer plus, how do I want to do it? Plus 0.5 pi times by answer, I think. It's probably the best way. And if I do that, I get 70.9. Okay. So I'm just going to check my answer in the mark scheme. Yeah, I get a value of x is 22.6 and the perimeter is 70.9. Okay, all right. Okay, so here we are in the last question of the paper, which is a vectors question. Diagram shows a triangle OBC where the ratio of OA to OB is 4 to 7, sorry, and OD to OC is also 4 to 7. We're going to call the vector O to BB and O to CC. The point P is the intersection of the lines A to C and B to D, such that A to P is equal to lambda AC and B to P is mu BD, where lambda and mu are scalars. We want to find two expressions for the vector OP, each in terms of B, C, and a scalar, and hence show that P divides both AC and DB in the ratio of 4 to 7. All right, now then, I think the way we want to analyze this is really by understanding what's going on here, right? So this line here, or this expression here, AP is equal to lambda AC. I'm going to highlight in green. Okay, that's that. And that is referring to this line here, right? That's that line there. And this one, BP is equal to mu BD, is referring to that line there. So the point P is going to be the intersection of those two lines. So what I want to do is I want to define the vector OP in terms of both the green line and the blue line. Okay, so how can I do it in terms of the green line? Firstly, I've got to go from O to A, and then from A to P. So that's what I'm going to write. I'm going to say OP is equal to O to A plus A to P. But what is A to P? Well, A to P is equal to lambda lots of A to C, right? Because that's what we're told in the question, right? So we've got lambda lots of A to C. All right then, well that means we've got to find out what the vector OA is. Well, OA, right, is along the line of O to B. Now we are told in the question that the ratio OA to OB is 4 to 7. So OA is 4 and OB is 7, right? That's 7. So the vector OA is 4/7 of OB, right? So I can write that OA is equal to 4/7 of the vector OB. Okay? And how can I write the vector A to C? Well, the vector A to C is going to be the vector OC minus OA. Okay, that's that thing there. And if you're not sure about that, right, I want to go O to C. That's the same thing as going, how do actually, do I want to, yeah, I'll do it that way. If I want to do the vector, AC, that's the same thing as doing A to O, which is negative OA, plus O to C, right? So let me just clarify. This thing here, AC, that vector, is equal to A to O plus O to C, and A to O is negative OA. All right, now then, let's simplify this. So 4/7 of OB, well, we can replace the OB, just call it vector B, plus lambda. We can replace OC with the vector C. And OA, we already said that's equal to 4/7 of OB, so this is negative 4/7 of the vector B. So now if we were to simplify all of this, how many B's have we got? Well, we've got 4/7 of B minus lambda lots of 4/7 of B. So I can factorize that as being 4/7 minus lambda lots of 4/7 times by the vector B plus lambda lots of C, right? So that's an expression for OP in terms of BC and the scalar lambda, right? So we've already done that. Well, now what we've got to do is we've got to do the same thing, but not following the green line, following the blue line, right? Following the line B to P. So let's do that. So I'm just going to divide that off so that we're not confusing. So how do I follow the blue line? Well, I'm going to go from O to B and then B to P. So I'm going to write that down. The vector O to P is the vector that takes me from O to B and then B to P. Okay. Now the vector OB is we just call it B. And what's the vector B to P? Well, it is equal to mu lots of BD, right? Because again, we're told that in the question, right? That's mu lots of BD. So then what is BD? Well, the same as in the previous part, that's equal to the vector OD minus OB. Right, let's go to the diagram and make sure we're okay with that. So what's the vector B to D? Right, well, we could go B to O, which is negative OB plus OD, right? So B to D is the same thing as OD minus OB, okay? And let's try to simplify that out. So we've got B here plus mu. Now, what is OD? Well, we're told in the question that the ratio OD to OC is also 4/7, right? So that distance there is 4, that distance there is 7. So OD is going to be 4/7 of OC, right? So OD is equal to 4/7 of the vector OC. And OB is just B, right? So we got that there. And if we were to simplify this, therefore, we've got B minus mu B. So we've got 1 minus mu lots of B. And for C, because OC is just C, we've got plus 4/7 mu for the vector C. Okay, so what have we done? We've got two expressions now for OP, each in terms of BC and a scalar, and we want to show that P divides AC and DB in the ratio of 4/7. In other words, what we want to do is want to find lambda and mu. Okay, so we can do this by comparison because these two vectors, this vector and this vector, are the same, right? Because they're both O to P. Then we can compare the components of B and also the components of C. So the component of B here is 4/7 minus lambda times by 4/7. So 4/7 minus lambda times 4/7 is going to be equal to the component of B over here, which is 1 minus mu. So 1 minus mu, okay? And I think we'll simplify that. I'll times both sides through by 7, I guess. So we got 4 minus 4 lambda is equal to 7 minus 7 mu. And I will add the 7 mu to the left-hand side. So we get minus 4 lambda plus 7 mu is equal to 3. Okay, so I'll call that guy, I guess, equation 1. Okay, and then what I'm going to do is I'm going to compare the C's. So on the left-hand side, I've got lambda. So I'm going to compare the C's now. So I got lambda is equal to 4/7 of mu, right? 4/7 of mu. 4/7 of mu. And that's equation 2. So we've got simultaneous equations, right? So what's the best way for me to deal with this? Well, I'll just substitute in lambda, I think, into equation 1. So therefore I can say, therefore, minus 4 times by 4/7 of mu plus 7 mu is equal to 3. I'm going to multiply everything through by 7, right? So negative 16 mu plus 49 mu is equal to 21. And 49 minus 16, what's that going to be? That's going to be 33? 33 mu is equal to 21. And so mu is equal to 21 over 33. And that divides through by 3, doesn't it? That becomes 7 upon 11. So my mu value is 7 upon 11. And what's my lambda value? Well, lambda will be 4/7 times by that. So lambda will be equal to 4/7 times by 7 upon 11, which is 4 upon 11. Now what does that mean? If we go back to the question, right? AP is equal to lambda lots of AC. Right, so AP is lambda lots of AC. Well, we've just learned that lambda is, where was it? 4 upon 11. So if we were to go back, this length here, A to P, that length we're saying is 4, and A to C is 11, right? So that length there has got to be 7, right? It's because 4 plus 7 is 11. And the same thing applies with BP is equal to mu BD, right? If BP is equal to mu BD, then if mu is equal to, where was it? 7/11, okay, then this length here will be 7, and this length here will be 4, right? Because, 7 plus 4 is 11. So we are asked to show that P divides AC and DB in the ratio 4/7, and that is exactly what we've done, right? Because this is the ratio 4/7, and this is also the ratio 4/7. So we have completed the question. Okay, part B, the point Q is such that O to Q is equal to 2/7 B plus 2/7 C. We want to use a vector method to show that O, Q, and P are collinear. Now, what do we mean by collinear? We basically mean that they're all on the same line, right? So linear is line, and co is a Latin prefix, which kind of means together or with. So basically what you want to imagine is here we got a line, like that. And O, P, and Q are all on the same line. So here's O, here's P, and here's Q. Now, if that's the case, then we know that the vectors O to P must be parallel to P to Q, or O to P is parallel to O to Q, and so on and so forth, right? So if we can show that OP and OQ are parallel, then we've also shown that they are collinear, that they're on the same line, okay? And what's the condition for two vectors to be parallel, right? One must be a scalar multiple of the other, right? So the vector A is equal to some scalar K times by the vector B. That means that the A and B are parallel to each other. So we should already have a equation for OP. So let's use this one here that we got previously. So we got 1 minus mu B plus 4/7 mu C. Now what was our mu? Our mu was 7/11, wasn't it? So 1 minus 7/11 is 4/11. So OP is equal to 4/11 of B, and we've got 4/7 times by 4/11. No, 4/7 times by 7/11, wasn't it? 4/7 times by 7/11 C. And if that cancels off, right, then we're going to get 4/11, isn't it? So let's just get rid of that. 4/11 C. Okay. Well, hang on. That is definitely going to be parallel to that, isn't it? Because if you think about it, I can actually factorize this and write that as 4/11 B plus C, and OQ is equal to 2/7 B plus C. And so I don't know exactly how you want to write it, but you could say basically OP is equal to some constant times by OQ. So OP is equal to some constant times by OQ, and therefore OP and OQ are parallel. And if OP and OQ are parallel, then the points OP and Q will be collinear. Okay, and that's how you want to do that. If you want to get the constant, by the way, the constant would be 4/11 over 2/7, wouldn't it? Which is 4/11 times by 7/2. So I think that would be, oh my goodness, I'm getting a bit slow. 14/11. Okay, so OP is equal to 14/11 of OQ. All right, and that will be your answer.